All right, my friends, let's take a look here at part A. So I'm just going to do the partial fraction decomposition off to the side, and then when I'm done, I'll replace 1 over 4x squared minus 9 with what I get. So remember, step 1 is factor the denominator. Step 2 is write the form of the decomposition. Something that's an easier thing to explain now that you are in Calc BC than it was last year when you were in pre-cal is why is the form like this? Well, now that you're calculus students, I hope it makes sense that if we could get a and b to be constants, then those would be integrals that are pretty easy for us to do. And so that's why. So hopefully that makes sense. So anyway, let's see, common denominator, we'd end up with a over 2x plus 3 would get multiplied by 2x minus 3 over itself, and b over 2x minus 3 would need to be multiplied by 2x plus 3 over itself. Okay, let's see, distributing a in, we'd end up with 2ax minus 3a plus 2bx plus 3b, and it's all over 2x plus 3 times 2x minus 3. There we go. And the whole thing was supposed to equal 1 over 4x squared minus 9. Okay, so I just won the denominator battle. The denominators do equal each other. So now I just need to make the numerators equal each other. So I need 1 to equal this big mess. So this would yield that I'm looking for 2a, actually, you know what? Let's skip a step here. Let's group the x terms together and factor the x out. So 2a plus 2b times x, and then let's group the constant terms, negative 3a plus 3b together. And we want this to equal that 1, and I'm going to think of the 1 as 0x plus 1, which should help with setting up my system of equations. So at this point, I know that I want 2a plus 2b to equal 0, since that's my number of x's, and I want negative 3a plus 3b to equal 1. There we go. Let's see, this first row, I hope it makes sense. You could just divide the 2 out, and it would say a plus b equals 0. And then I'll just show substitution instead on this one. So I'm going to subtract the b over. So a is the same as the opposite of b. And then you take this and sub it in for a in the second equation. So we would end up with negative 3 times negative b plus 3b equals 1. So it looks like we'd end up with 6b would have to equal 1, which means b would have to equal 1/6. Since b is equal to 1/6, back substitute in up there, and you'd find out that a would have to be negative 1/6. There we go. All right, my friends, once you have this, you could take that and back substitute it into your form. So what does that tell me? It tells me that I could replace this integrand over here with negative 1/6 over 2x plus 3 plus positive 1/6 over 2x minus 3. There we go. All right, and then from here, it's, you know, there are a couple different ways to handle this depending on what you do with the 1/6. I have a tendency to just factor them out. So like maybe I do negative 1/6 times the integral of 1 over 2x plus 3. You could also factor 1/2 out. I've seen people do that as well. I need a little space here, so I'm going to move this out of the way. And then I'm going to factor the 1/6 out of the second one. This one is a little interesting because it depends on kind of what you factor out and what you don't at this stage, as far as like how your answer looks when you're done. So on this first one, I'm going to go ahead and let u equal 2x plus 3. And then notice that the du for that would be 2 times dx. So the dx that you see here would be worth half of a du. So I'd have the negative 1/6 that I already have out front, and then the 1/2 from the 1/2 du, and then I'd have 1 over u du. So this first integral, my friends, would end up being something equivalent to 1/12 times the natural log of the absolute value of u, which I'm going to back substitute in as 2x plus 3. And then I'd be done with that one. And then similarly, since if I was to let the plus 3 here in my u substitution, if I was to let plus 3 be a minus 3, nothing else really would have changed. I hope it makes sense that the antiderivative of the second one would end up being 1/12 times the natural log of the absolute value of 2x minus 3 plus c. Boom. There you go. And logarithms are fun because you've got all these properties that you could use to, switch them up and stuff. But let's just say if you got to anything equivalent to this, then we'll call it success. For part B, the first thing I want to point out is that this is what's called an improper fraction. You can tell a rational function is improper when the degree of the numerator is not less, I repeat, not less than the degree of the denominator. And so the move in that case is to just use whatever form of division is appropriate. In this case, that would be long division, to write your answer in mixed fraction form. So let's work on that. So let's see, distributing that in. Did I copy that right? Yeah. Okay, subtract the whole row. Okay, and then the whole point is to get like the fraction part to be improper. So I hope it makes sense that like this part that I have here, I don't want that to be my remainder. So I need to go through the round again. So let's see. I think I did that right. Okay. And then from here, let's see, what could we do? We could rewrite this as x minus 1 plus 2x plus 1 over x squared plus x minus 2. Okay. Now from here, I'm going to split this into 3 integrals. So the antiderivative of x is x squared over 2. Antiderivative of 1 is x. And then I'm going to go ahead and just use a little dirtbag math on the last one, saying I promise I'll do it later. Anyway, now this last one, because we're in the section known as partial fraction decomposition, probably your knee-jerk reaction is going to be to start decomposing this fraction. But it turns out that every once in a while you're going to get away with trying something that we had in the past. And so for this particular one, if you let u equal the denominator, and I do hope that you still kind of like let your brain run through this as an idea, because it was easier than partial fraction decomposition. Your du would equal the quantity 2x plus 1 dx, which how adorable is that? Anyway, so you'd end up with x squared over 2 minus x from the previous work. And then your second integral, if you write it in terms of u, would be the integral of 1 over u du. And so you could be done pretty quickly. You could also use partial fraction decomposition and end up in the same spot. But this is, I don't know, I really like this. Anyway, so plus the natural log of the absolute value of x squared plus x minus 2 plus c. Yay! There you go. All right, partial fraction decomposition dodged. There you go. Okay. All right, my friends, one more example. So for example 3, instead of having you do the integral every time, I do think this lesson, for the most part, we should just focus on making sure you're really good at doing the partial fraction decomposition part. So go ahead and see how it goes. You're just looking to decompose 5x squared minus 12x minus 12 over the quantity x cubed minus 4x. See how it goes. Check in with me in the next video.